Welcome to ZoomInData. Hello everyone. Thank you for joining the fifth video in our comprehensive Azure Logic Apps series. In this session, titled Actions, Performing Operations in Workflows, we will delve into the definition and role of actions as the core processing units following a trigger. The main categories of actions, including control flow, data operations, service invocations, and custom code execution. How actions process data, control execution paths, and integrate with external systems. Best practices for using actions effectively in robust, scalable workflows. Understanding actions is essential for building intelligent, resilient automations and forms the backbone of practical workflow design. If you find this content valuable, please subscribe to ZoomInData and enable notifications to follow the complete series. What are actions in Azure Logic Apps? Actions are individual operations that execute after the trigger in a workflow to perform tasks, process data, call services, or control flow. They handle business logic, data transformation, external integrations, and decision-making. Each action can reference outputs from previous steps using dynamic content. Why are actions essential in every Logic Apps workflow? Actions execute the actual work after the trigger fires, turning events into meaningful outcomes. They enable data manipulation, conditional routing, looping, service calls, and error handling. Without actions, a workflow would only detect events without performing any processing. What are the primary categories of actions? Control flow actions. Manage logic with conditions, switches, loops, scopes, and branches. Data operation actions. Perform transformations like compose, parse JSON, filter arrays, and create tables. Service invocation actions. Call external connectors or built-in services. Custom code actions. Run inline scripts or Azure functions. Explain control flow actions and their purpose. Control flow actions direct workflow execution based on conditions or states. They include condition, if, else, switch, multi-branch. For each, array iteration, until, loop until condition met, and scope, grouping for error handling. These enable branching, repetition, and structured organization of complex logic. What is the condition action and how does it work? The condition action evaluates a comparison, e.g., greater than, equals, and executes different paths based on true, false outcome. Supports dynamic content from previous steps and expressions for complex logic. Commonly used for approvals, filtering, or routing. Describe the switch action. The switch action routes execution to one of multiple cases based on a value, e.g., status code or category. Includes a default case for unmatched values. Ideal for handling multiple outcomes cleanly without nested conditions. How do looping actions function in workflows? For each loops process each item in an array or collection sequentially or in parallel. Until loops repeat until a condition is met or a state changes. Loops support batching and concurrency limits for performance. What is the scope action and its benefits? Scope groups related actions for organization, collective error handling, and run-after behavior. Enables try-catch patterns by configuring run-after on failure. Improves readability in large workflows. What are data operation actions and common examples? Data operations manipulate content without external calls. Common ones: compose, combine inputs, parse JSON, tokenize JSON, filter array, subset based on condition, select, map properties, join, concatenate with separator, create CSV, HTML table. Essential for formatting data for downstream steps. Explain the parse.json action. Parse.json creates user-friendly tokens from JSON properties for easy reference. Requires a sample schema or dynamic generation. Simplifies handling outputs from services like Service Bus or Cosmos DB. How does the compose action work? Compose creates a single output from multiple inputs, expressions, or variables. Supports any native type, arrays, objects, strings. Useful for intermediate calculations or message construction. What are service invocation actions? These actions call external services via built-in or managed connectors, e.g., send email, HTTP request, SQL query. Built-in run natively for performance. Managed require connections. Include HTTP, Azure functions, and connector-specific operations. Describe custom code actions. Inline code action runs JavaScript, C#, or PowerShell snippets directly. Azure Functions Connector invokes reusable functions. Extends workflows for complex logic not covered by built-in actions. How do actions handle inputs and outputs? Actions receive inputs from trigger or previous actions via dynamic content or expressions. They produce outputs, JSON objects, available to subsequent steps. Use expressions like @body, action name, for referencing. What is run after configuration? Run after defines when an action executes based on previous action status, success, failure, skipped, timed out. Enables fallback paths, error handling, and conditional sequencing. Critical for resilient workflows. How do actions support parallelism? Parallel branches allow multiple actions to run simultaneously. For each loops can enable concurrency for faster array processing. Improves performance in independent tasks. Explain retry policies on actions. Retry policies automatically retry failed actions on transient errors. Configurable with count, interval, and backoff strategy. Enhances reliability without custom code. What are batching capabilities in actions? For each and until support batching to process items in groups. Reduces execution overhead in high-volume scenarios. Available in both consumption and standard models. What are batching capabilities in actions? For each and until support batching to process items in groups. Reduces execution overhead in high-volume scenarios. Available in both consumption and standard models. What best practices apply when using actions? Use scopes for grouping and error handling. Prefer built-in for performance. Optimize loops with concurrency limits. Test with sample data and monitor runs. How do actions differ in consumption versus standard? Both support core actions. Standard offers more built-ins, e.g., XML, Liquid Ops. Standard allows local development and higher limits. Core functionality remains consistent. Describe a practical example of action usage. Trigger, new email. Action 1, parse JSON, email content. Action 2, condition, check priority. Action 3, send Teams notification if high. Action 4, create task in Planner. How do actions contribute to workflow resilience? Through run after, scopes, retries, and termination actions. Handle failures gracefully with fallbacks. Support idempotency for at least once delivery. What role do variables play with actions? Initialize variable stores data. Set variable updates it. Used across actions for counters, flags, or temp storage. Limited to 20 per initialize in some cases. Why are actions key for interview and design questions? They demonstrate ability to implement business logic, error handling, and optimization. Frequently tested in scenarios involving control flow and data transformation. Essential for building production-ready integrations. Thank you for watching this session on actions in Azure Logic Apps workflows. If you found this video helpful, please like, share, and subscribe to ZoomInData. More Azure Logic Apps interview and tutorial videos coming soon. Stay connected and keep learning.